bitwise operator. So so here we will speak about binary system and some operator in C language that work with the binary system. Okay. Of course, in the lab you will take more examples, and also I will try to send you more examples. Okay. So this last subject with us. Next week you have the final exam. I think you already have the schedule for your final exam. As I remember, it's I think on 16 June, something like this evening. So prepare yourself for the exam. I think it's almost like the midterm exam, the way of the final exam. Okay. So bitwise operator. Here we will speak about operators in C language that work with bits. Bit means 0 or 1. Yes, the binary system. And we will see these operators and how it's work, and we will take some examples. Okay, so binary system, you know the binary system. In the binary system, each digit in the number will be 0 or 1. So, as we know that computer will code everything, will convert everything into binary system. So, if this number is a binary, how to know what exactly or how much exactly this number in our decimal system? It's like this. Each digit in the binary have the, let's say, the position value, yes, for the number. Okay, so each position is starting from right to left. You can consider this position 0, so its value 2 or 0. This position 1, its value 2 or 1. This its value 2 bar 2, 2 bar 3, 2 bar 4, and so on. So to get the number in the decimal system, you have to multiply the value with the digit. If it's 0, then you can remove the value. If it's 1, you can take the value like this. So this number here, what's the value? This 2 bar 0, 2 power 1. This is the position for each one. 2 bar 0, 1, 2, 3, 4, and so on. So 1 multiplied by 2 power 0, it's 2 power 0. Then plus the second digit. 1 multiplied by 2 power 1, so it's 2 power 1. Plus 0 multiplied by 2 power 2, so it's 0. plus 0 multiplied by 2 power 3, it's 0, plus 1 multiplied by 2 power 4, so it's 2 power 4. So you can sum the power, it's 2 power, let me just check here, 2 power 0, which is 1, plus 2 power 1, which is 2, plus 2 power 4, which is okay, 1, 2, 4, 8, 16. So the result will be 19. Okay, so like this, you can know the value of the binary number in decimal number. And you can make a program to do this. Okay, what if we can make it much easier if we do it like this? So we are speak about a binary system. So the base is 2. So first one is multiplied by 2 power 0, which is 1, yes? Second one with 2, 4, 8, 16, and so on. It's multiplication of 2, 32, 64, 128, and so on. Okay, so we have another um, system for numbering system. Also, it's used in the computer, especially in the operating systems and so on, which is hexadecimal numbering system. Hexadecimal is used 16 different symbols. Okay, if we speak about numbers, we know numbers from 0 to 9 or to 10, yes? So this digits from 0 to 9. Okay, what after this one? 0 to 9. We need 10 in hexadecimal. So we cannot write 10 like this because this means 1 and 0. We need a new symbol for the 10. So we use letters starting from A for 10, B for 11, C, D, E until F for 15. So in hexadecimal system, 0 until 9, 10 means A in the hexadecimal system, 15 it's F. Why 15, not 16? You said 6 different symbol because we started from 0. So we have from 0 to 15, which is F. So how to know the value of the hexadecimal system? When you write like this means it's hexadecimal system. If you write like this, the number, then you mean it's our decimal system that we know it. We have numbers also with octa system. Okay, you have to know that this means what's the system. This octa system, this hexadecimal system, this decimal system, and so on. And if we put 2 like this, it's binary system. Okay, so we have these numbers with hexadecimal system. What's the value of these numbers? Same idea like binary system. In the binary system, the position it's 2 power 0, 2 power 1, 2 power 2, and so on. In hexadecimal, the position is 16 power 0, 16 power 1, and 16 power 2, 16 power 3, and so on. So this is the value of the position. You can multiply it by the number and make summation. So C it's 12, yes? So 12, which is C, multiplied by 16 power 0. 16 power 0, it's 1. So 12 multiplied by 1, it's 12. Okay, F multiplied by 16 power 1. This is a position, 16 power 1. So 16 power 1, it's 16, and F is 15. So it's 15 multiplied by 16, which is 240. Plus third digit, which is 3, multiplied by 16 power 2. So the result 768. I don't know 16 power 2 actually without calculating. Anyway, so the summation is 1020. What's this 1020? This is a 3FC. So 3FC in hexadecimal, it's equal 1020 in the decimal system. Okay, same idea here. 1FA9 in hexadecimal, you will multiply each digit with the value of the position. 9, its value, the position value 16 power 0. A, its value 16 power 1, 16 power 2, 16 power 3, and then multiply and make summation for the value of each digit. It's same from any system. For example, if we said 65, okay, it's in octa system. How much it will be in decimal system? Same idea. 5, its position 8 power 0. 6, its position 8 power 1. So it's 5 multiplied by 8 power 0, which is 1, plus 6 multiplied by 8. So it's 5 plus 48. So it's 53. This in decimal system, our numbering system, and this in octa. So now we know how to convert from any system to a decimal system. You need to take digit by digit and then this digit, multiply it by its position bar, then sum all the digits. Okay. In binary system, we also have a sign, means plus or minus for the number. So how to use the sign in the binary system? Variable in C language, it's either signed or unsigned. Can be signed, can be unsigned. Signed means you have plus or minus. Unsigned doesn't matter the sign. It's always plus without sign. This means. So if you have, for example, 8 bits, which is 1 byte, and it's signed, so the most left one is the sign of this number. So we consider this digit as sign. If it's 1, means negative. If it's 0, means positive. So 1 means negative, 0 means positive. Okay? This is a sign of the number. Okay, now when we speak about signed binary, here, this one, it's work if it's unsigned. But what about signed? If this signed, this mean this is not part from the number, it's the sign, yes? So how to convert signed to decimal number? It's not like this because we consider last one, it's signed, but here's this example for unsigned binary. So let's see in the signed binary, what's the difference? When we speak about decimal or convert binary to decimal, and we have signed number, signed binary number, this means last digit, this one, it's the sign. So it could be positive or negative. Negative means 1, positive means 0. So it's work like this. Also, we will multiply each one by the position, okay? Except last one, we will multiply it by the position with minus sign. So this one, it's position 0, so it's multiplied by 2 power 0. This one is position 1, so it's multiplied by 2 power 1. This one, it's position, it's the sign, and it's position 7, so it will multiply by 2 power 7, but with the sign, minus sign. Okay. Why minus? Because if the number is minus, it will be minus this sign, then you will get the minus number. And if the number is positive, this one will be added, like the unsigned one will be added to the summation. So let's take those examples. Okay, so here we have some signed number and some unsigned number. Same number, we will see the result with signed or unsigned. Okay, if we speak about signed number here, this one, let's take it aside, okay? This 2 means it's a binary system. Let me just check. This one, I will make it. Where is the position? I forget it. Okay, later I will make it down. Oh, just close this one. I will copy the number here and try to see it. Yeah, no. We need just any empty place and copy this number. Okay, we speak about this number as assigned. True. Okay. So we see this number as signed number. So I will multiply each one with the position. So this one multiplied by 2 power 0. And here, don't forget, this one is the sign. Okay. This one multiplied by 2 power 1. 0 multiplied by 2 power 2. 1 multiplied by 2 power 3. 2 power 4. 2 power 5. And 0 multiplied by 2 power 6. And this one, the sign, it's 1 multiplied by minus 2 power 7. Okay, so this 1, 2, 0, 8, 16, 32, 0, because 0 multiplied by 64, so 128 minus. Add them. So we have here 59, and here plus minus 128. So it's equal minus 69. So this is a number. It's minus 69. Okay. Why? Because it's signed. If it's unsigned, it will be different. Let's see if it's unsigned. If it's unsigned, then we don't have minus here. Okay, we will have same numbers, but without sign, so without minus. So in this case, we have 1, 2, 8, this one 0, 16, 32, which is 2 power 5, and this one 0, and this one 128. Then we can make the summation. As I remember, we have this one 59 plus this which is 128. So it's equal 781. Okay. So this is a number 187 because it's unsigned. When it's signed, it's minus 69. Okay, same idea. You can try the other numbers. I don't want to waste the time. Convert other numbers. Same idea here. For example, 1, 4, 8. Okay, 16, 32, 64. and this one minus 128. So 64 plus 13, which is 70, yes, because here 72, 76, 77. So if you make minus, so it's minus 51. If it's unsigned, instead of this minus, it will be plus. So that's all about signed or unsigned binary number. So signed number, binary number, last digit is the sign, and to use the sign, we make the minus of the sign plus the remain number. Okay, what's the bitwise operator? It's operations for or some operators that used in C language with a binary number. So when you use this bit operators, we use it with integers. Okay, so bitwise operator can be applied for integral operands, means values at integral or variables at integral. What's the meaning of integral? Integer, short, long, signed integer, unsigned integer, character. All this consider integral. What is an integral? Means that have decimal point. This is an integral. So you cannot apply this bitwise operator for non-integral operand like float or double. So bitwise operator cannot be applied for float and double because it's have decimal point, okay, have fraction. So it's only for integrals, means numbers that do not have fractions. Like character, it can consider as number in C language, okay, short, integer, long, and signed and unsigned integer. Okay, what operators we have? And we will speak about the usage of this operators. Okay, we have this operators, and okay, this it's different than this and. This and we use it with the conversion, yes? Here, single and alone, this it's bitwise operator, and it's used with the numbers. So the computer sees the numbers. When you set 5, the computer see it as binary. So 5, it's 1, 0, 0, or 1, 0, 1, 0. See it like this, the computer. And if you said we have 4, so the computer see it as 0, 0, 1, 0. So if you make 5 and 4, the computer will make like this. 5, which is 0, 1, 0, 1. And 4, which is 0, 1, 0, 0. And make the operation, which is and but what bitwise. So how it's work? It's work digit by digit. So it's take bit from the number and make and between the corresponding numbers. You know the and operator. Okay, if we have 1 and 1, the result will be 1. Otherwise, the result will be 0. So if we have 0 and 1, the result 0. 1 and 0, the result will be 0. 0 and 0, the result will be 0. So it's work like this. You make the AND operators between numbers, compiler see it as binary, then make the AND operator for each corresponding result or digit. So it will see it like this. For example, 5 and 4, this 5, this 4. So take each corresponding digit, 1 and 0, it's 0, 0 and 0, 0, 1 and 1, 1, 0 and 0, 0. So 5 and 4, the result will be 4. And so on. So this and bitwise operator. Or you remember this or for comparison. This for comparison in the if statement, in the while statement. But if we speak about bitwise operator, we take only one line like this. So this or in the bitwise operator. So same idea like AND, but the result will be like this. If the corresponding digits have any side have 1, so 1 or 1, the result will be 1. Any side 1 or 0, the result 1. 0 or 1, the result 1. Only if both sides 0, the result will be 0. So this is a bitwise or. Okay. What about this operator? You know it as power. Yes, it's actually, if you try it in C language, it's not power. In some other programming languages, it's power. But in C language, it's not actually power operator. That's why in C language, we use a function from the mathematic for the power. Or you have to create your program as for loop or while loop to make the power. Okay, we already talked how to create function for the power. But this operator, it's not a power. It's actually something called XOR, exclusive or XOR in the bitwise operator. What's the XOR? XOR actually, if the digits same, will give you 0. If they are different, will give you 1. Okay, so the result are set to 1 if exactly one of the corresponding bits is 1. This means the other one is 0. If both 1 or both 0, the result 0. So if they are same like this, 0. Same, 0. Different, one side is 1, other side is 0. The result will be 1. Okay. Left shift. Left shift, it's work like this. You have the number and you will make shift. Then there is 2 operand. Here, the number that you will make the operation on it, on the left side, and on the right side, how many digits you will shift. For example, 1. What's the result for this one? It's shifting the bits of the number to the left, because this left shift to the left and fill from the left by 0. So if we shift 2 digits or one digit or three digit means fill from the left by zeros, depend on the shift. For example, here, 5, which is 1, 0, 1, 0. If we shift it by one digit, means all the digits will be shifted. Here, 1, it's come here. What about this one? It's gone. It's 1 or something, it will gone. This one will be shifted here. This one will be shifted here. And the position will be filled from the left by 0. So 1 shifted by here, 0 shifted by here, 1 shifted here, and this position will be filled by 0. So 5 shift by 1, it's become how much? It's become like this. So this 1, 2, 4, 8. So 8 plus 2, which is 10. It's like you multiply it by 2, by the way. So if you shift it by 1, okay, what if I shift it by 2? If you shift it by 2, it's like this. This 5, we shift it 2 digits. So this one, 1, 2 digits. Let's go outside. 1, 2 digits. So this digits become 0, 1, 2 digits. This one, 1. And this filled by 0. So it's 1, 2, 4. So it's become 4 when you shift it by 2 digits to the left. Okay, what about this one? This one is shift to the right. Now shift to the right, it's same idea like shift to the left, but we fill in the right. Okay, so we shift the digits from the right to the left, like this. If we have this number, and we want to shift it to the right 2 digits. We have one question here. Is it a signed or unsigned integer? Because there's different. If this unsigned, we just shift 2 digits and fill by 0. So this 2 digits will gone, and we will add 2 digits in the left side because we shift to the right. This if it's unsigned. What if it's signed integer? If this one signed, then the shift different. We will look to the most left digit, which is the sign. If we speak about unsigned, so this is the sign for the number. Yes? So it says like this, shift and fill by same like the sign. So if this one sign integer and the sign is 1, then you shift 2 digits and you fill by same digit like the sign. So you fill by 1, 1. Why? Because the sign digit 1. Okay, look to this number. 0, 1, 1, 0, 1, 1, 1, 1. Also, it's a sign integer. Okay, but the sign, as you can see, is 0. Now we want to shift 2 digits. Okay, 2 digits to the right. So this 2 right digits gone. And we add 2 digits here. Same like the sign. So the sign is 0. So we will add 0. So this is a difference between right shift and left shift. Left shift, always we fill by 0 from the right and we take the digits from the left because we shift everything. Okay. This one complement operand, or we know it between us as a not, yes? So if the bit is 0, it's become 1. If the bit is 1, it's become 0. Okay, so let's take now one by one. So as I told you, this is the AND bitwise operand. And I told you it's different than the comparison. Comparison, you have two ANDs, yes? Here we have only one operand, okay? So if even in the comparison, if you put something like this, only one, it will not consider it as comparison. The compiler will do the operation. So if you said if something, for example, x and y, it will not do any comparison. It will make operation here, which is bitwise, and then after do this, the result, if it's equal 0, then it's false, else it will be true. Like this, the compiler will consider it. So this one, it's operator not connect between condition using and or. No, this one operation or operator for bitwise and. Okay, so we already mentioned this bitwise and. Actually, for example, if we have like this operation, 5 and 3. 5 and 3. How come it's become 1? The compiler will take the 3. So 3 it's 0, 1, 1. 5 it's 1, 0, 1. How to know it? We know that the position. Okay, the position system in the binary, it's 2 bar 0, 2 bar 1, or 1, 2, 3, okay, 4, sorry, 1, 2, 4, 8, 16, 32, and so on. So if we need 5, so 5, it's 1 plus 4. So 1 and 4, and the remainder will be 0. This 5. Okay, you need, for example, 10. 10, it's 2 with 8, and the remainder will be 0. You need, for example, 38. Okay, 32 plus 4 plus 2, and the remainder will be filled by 0. So this one, 38. This one, 10. And so on. So 5, it's 1, 0, 1. 3, it's 1, 1. Okay, and the remainder will be 0. This is a 3. Okay, now make the AND bitwise operator. So 1 and 1, digit by digit, 1 by 1, 1 and 1, it's 1. 0 and 1, it's 0. 1 and 0, it's 0. Because we said if both side 1, the result 1, otherwise the result will be 0. What about bitwise OR? Same idea. If we have this 5 or 3, so 5, this 5, this 3 and this OR. So we take digit by digit. If any side 1, the result 1. If both sides 0, the result 0. Okay, so 1 and 1 or 1, it's 1. 0 or 1, it's 1. 1 or 0, it's also 1. So what's this number? This 1, this 2, this 4, plus, so it's equal 7. So 5 or 3, it's equal 7. Okay, what about the XOR or exclusive OR? We said if both sides similar, the result 0. If both sides different, the result 1. So if we have 2 zeros or 2 ones, the result 0. Why we use this XOR? Actually, we use XOR usually, okay, to toggle the bits between 0 and 1. What's this mean? This means if we want to flip means make 0 as 1 and make 1 as 0. So if you have a number and you want to convert each 0 by 1 and each 1 by 0, you just make XOR with 1. Any digit you make its XOR with 1, it will be flipped. If it's 0, it's become 1. If it's 1, it's become 0. So this is a usage. But what about make XOR between numbers like this? Okay, same idea. This 5, this 3. XOR means take, if they are same, the result 0. They are different, 0 with 1. So the result 1, 1 with 0, the result 1. So how much this one? This one 2 plus 4, which is 6. Okay, this just organize all the operation in same slide. So if you have A and B, this all the possibilities. So and means only if both side 1, the result will be 1, otherwise 0. Or if both sides 0, the result will be 0, otherwise the result will be 1. XOR, if they are same, the result 0. Same, the result 0. Different, the result 1. Okay. Shift. I already mentioned the shift. I don't want to repeat it again. So, what's the usage of shift operator? Okay. Usually, it's used the right shift to divide the number by 2. Okay, by make shift by 1. If you make shift by 1, then it's same like you divided the number by 2. We already took this example or example similar. Okay, just 1 minute, I'm coming. Okay, just 1 minute, coming. Okay, I'm back. So, so the shift, as I said, uh, it's used to shift the numbers, but if you shift by one digit, means you are divided by 2. This example, 10, of course, we speak about 10 in decimal number if we shift it by 1. So 10 in binary number, it's 0101. Shift by one digit, so we speak about right shift. So right shift means we shift like this. Of course, we speak about here in this example about unsigned. Okay, so if it's unsigned, we shift by one digit and fill by 0. So it's become 0101, which is 5 because this one 1, this 4. So 1 plus 4, it's 5. So it's like we divided by 2. The opposite, if we make uh, left shift by 1, it's like we multiply by 2. Okay. What's the other uh, use here? Okay. We use the shift actually too much. Okay. With something called masking. We will see how to use it uh, in the next example. But let's speak about sign. If we have sign, as I told you, if we speak about signed number, this means the most left digit, it's the sign. So if this sign 0, we fill by 0. If this sign like this 1, so if we shift this one to the right, 3 digits, and the sign 1, we fill by 1. If the sign 0, we fill by 0. Okay, what about left shift? Left shift, we don't care about the sign, by the way, because we will add the 0 from the right place and we make the shift to the left. So actually, it's like if we make shift by only one digit, it's like multiplying the integer by 2. So 5 shifted 1, it's equal 10. Why? This is the 5. Shift one digit. This means if we shift to the left, this one comes and 0 filled here. So it's become 1010, which is 10, because this one 2, this one 8. So 2 plus 8, which is 10. Complement operator, it's take only one operand, which is the number, and make like invert each byte. If it's 0, it become 1. If it's 1, it's become 0. So 5, it's 101. When we make the complement, each one becomes 0 and each 0 become 1. So it's become 010, which is 2. This one is position 2 power 1, which is 2. So the result is 2. Okay, let's speak about the usage. How to use this bitwise operator and why we use it. For example, we use OR operator, okay, to make a number's bit as 1. Okay, you need a specific bit to be converted into 1. Doesn't matter, is it 0, is it 1, you want to convert it as 1. In this case, okay, you just make like OR operator with the mask, we called it, okay, that have everything 0 except the position that you will convert it into 1, you will add 1 for it. So if you have this number and you want to be sure that this digit, I need this digit to be 1. In some cases, we need it, for example, to be sure about the specific input, specific digit in the input, we need to be sure that it's 1. How to do it? Like this, make OR with all 0. 0 means will not change anything. If you make OR with 0, you will not change anything. 1 will stay 1, 0 stay 0. But if you make OR with 1, you sure that the result will be 1. So you convert this 0 into 1. If it's 1, it will stay 1. If it's 0, it will convert it into 1. This means you are sure now, after you make this operation, you are sure that this bit is 1 by make XOR with 1. So to set a specific digit to 1, just make XOR with 1 in this position of the digit. Here, same idea. We sure now that this digit and this digit is 1. How? By make OR with all 0 except the position of this digit and the position of this digit as 1. Okay, so the result, same number, except that you confirm that this digit will be 1 and this digit will be 1. What if it's originally 1? It will stay 1. Okay, so what's the usage of AND operator? It's too much important, the AND operator here, because we use it to check a specific bit, if it's 0 or 1. Okay, what's the use of it? For the flags, for example, if I have flag to mention that a specific key in the keyboard, each key, for example, we give it a flag that we know that the user press enter or shift or control by digit or specific digit for each of these keys. So, for example, if the fifth digit is 1, means the user press shift, for example. If the 9 digit is 1, the user press tab or caps lock. Then how to check specific digit? To check specific digit, you make AND with a number, we call this number mask. The mask will be all 0 except the digit that you want to check. In front of it will be 1. Okay, then what's the result? The result will be zeros except this digit. If it's 1, the result 1. If it's 0, the result 0. So if the result of the mask will be 0, then you know that this, after add the mask, make AND with the mask, you know that this digit is 0. If the result of AND operator with the mask is all 0 except this digit 1, then you know that the original digit is 1. So we use it to check a specific digit if it's 1 or 0 by make mask that all the mask 0 except that digit in front of it we will put 1. Okay, this is one example for the usage of the mask. Imagine that we have uh, the information about the keyboard codes. Okay, so it's like this. We need, for example, 8 digits. 8 digits. This one, the keyboard information. First digit, which is digit index 0, it's for the right shift. If it's pressed, the digit will be 1. If it's not pressed, the digit will be 0. Second bit, which is its position 1, it's the left shift. If it's left shift pressed, this digit will be 1. If left shift not pressed, this digit will be 0. So if we have the keyboard information like this, like a set of bits, and we know that each digit position, like in this table, this is the position in the bit. This bit 0, this bit 1, bit 2, bit 3, bit 4, bit 5, and bit 6. Okay. Each one corresponding to the status in the keyboard. So to check a specific status, for example, I want to check if the numlock, on or off. Okay, to check if the numlock on or off, I will go to digit number 5 and I will check it. Is it 0 or 1? If it's 0, this means the numlock is off. If it's 1, this means the numlock is on. So I don't care about other digits. So I will make AND operator with mask. This mask all 0 except in front of the 5th position, which is the numlock position, will be 1. Okay. If the result of this AND operator with the mask give me 1 here, this means this one originally 1. If it's give me 0, then this bit is 0 and this means the numlock is off. Why? Because AND with 0 always 0. And with 1, it's depend on the other side. If it's 1, the result 1. If it's 0 with 1, the result 0. So like this, we check this digit if it's 0 or 1. Okay, let's see the example. Here, we want to check the numlock if it's on or off. Okay, to do this, we need to check the bit number 5. In our example, it's depend on the construction of the keyboard, okay? So, for example, in the information of the keyboard, 5th digit for the numlock. So we want to check 5th digit. If we want to check the numlock, okay, so we will check the digit number 5 in the key information data. For example, key information data, okay, usually it have 32 digits. Okay, but in our example, for simplicity, imagine that the information data is like this. So this is the information of the keyboard. Depending on this information, we need to know if the numlock on or off. Okay, to do this, we know that the numlock it's the fifth digit. So 0, 2, 4, 8, 16, sorry, 1, not 0. 16, 32, 64, 128. This is the value of each digit. The position of each digit, 0, 1, 2, 3, 4, 5. So this one, the fifth digit. Yes? So its value 32. So we will make mask as 32, which is fifth digit as 1. All other digit as 0. So digit index 0 is 0, index 1, index 2, index 3, index 4, index 5 will be 1, index 6 and 7 will be 0, 0 here. So this number it's equivalent to 32. So our mask is 32. It will be make as operation and operation with the original data. If the result 32 same like the mask, if the result same like the mask, then the bit was 1, so it's on. If the result 0, then this means the bit was 0, and this means the numlock was off. So this is a number. We take the number and we make AND operation with the mask. So as you can see here, 1 and 0, 0, and 0, 0, and 0, 0, and 0, 0. 1 and 1, the result 1. All other results 0. So what's the result is 32, which is here. You can see this position 1, 2, 4, 8, 16, 32. So the result 32, which is same like the mask. So this means the bit of the numlock is 1, so it's on. Okay, what if this one 0? If this one 0, if this one was 0 like this. So when you make AND with the mask, this one will become 0, so the result 0. When the result 0, we know that the original or the corresponding digit was 0, so the numlock was off. So like this, we check a specific digit if it's 0 or 1 by make masks that all the masks 0 except that digit as well. Okay, we take another example for this operation because it's important operation using the IPv4. You know the IP address, yes? V4 means version 4, which is like this, have 4 places, okay, in the IP address. IP address is address for each computer in the network, yes? Each computer in the network or in the internet have IP address. IP version 4, it's like this. We have 4 position in the address. Usually in the computer, IP address will be look like this, hexadecimal, okay? So what's the meaning of 0x? This one means the number is hexadecimal, and this is the number. So this the IP address, and this one to tell you that this number in C language like this. If it's a start with 0x means this is hexadecimal. You can make, by the way, any integer value, you can make its value as hexadecimal like this. By use 0x, then you give the number. Is it number? Yes. This 2, this 0, 1, 0, 8, this 10, because A it's equivalent to 10, this 0, and this A is 10, B is 11, C is 12. Okay, so C is 12. Okay, so here in this example, okay, we have the IP address like this. It's in hexadecimal format, and we will divide it into 4 parts, 4 segments, because the IP address actually have 4 segments. Okay, the computer consider each 8 bits, but you speak about hexadecimal. Yes, but when we make bitwise operator, the computer will see this as 0 ones. So the computer will see it as bits. Okay, each 8 bits in this number, actually it's corresponding into segments. So the idea like this, I will divide the number into 8 bits, and each 8 bits, I will print it as a segment. So the IP address actually will be 32 bits. Okay, so we have 32. Each 8 bit is corresponding to segment. Other 8 bits, it's the other segment. Another 8 bits, another segment, and another 8 bits, the 4th segment. So what I will do, we will take the IP address as hexadecimal, then we will divide it into 8 bits, and print each 8 bits on the screen as a segment, and we put this dot between each segment. Okay, it will work like this. Okay, to do this, first of all, we will use the idea of the mask. Okay, the idea of the mask, for example, you have this number. Any number. I want to take only this part, this digits. How to take this digits and ignore all other digits? By make and with masks that everything 0 except corresponding to this digits 1, 1, 1. So like this, okay, make and with this mask. So 0 and 0, 0, 0 and 0, always 0 because you have one side 0. And this one depend on the original data. So 0 and 1, 0, 1 and 1, 1, 0 and 1, 0, 1 and 1, 1. Look, we convert everything into 0 except the 4 digits that we need. So this is the idea. We have the IP address. I will make AND byte operator with mask. This mask, everything 0 except the first 8 digit will be 1, which is in hexadecimal. This one, it's like 8 digit 0, 8 digit 0, 8 digit 0. This 8 digit as 1. So this is a mask in hexadecimal. FF, it's corresponding to 1, 1, 1, 1, 1, 1, 1, 1. So this is a mask, 8 digit as 1. What's the meaning of 0x? As I told you, means the number is hexadecimal. It's not part from the number. It's to tell the compiler that this number is hexadecimal. Okay, so the idea like this. If we have this, the value of the IP address, which is in hexadecimal like this. So this in binary, this in hexadecimal, this in decimal, the value in decimal. Okay, so 3 systems, yes? Doesn't matter, you don't need to convert it now. So this binary, this hexadecimal, this the decimal, this is the IP address value. Now to divide it into bars, we need this 8 digit. Okay. To take this 8 digit, we will make AND operator with mask that everything here 1, or the 8 digit here 1, and all other parts 0. So if you make AND, you will convert all this into 0, except this part, you will take it as it, as you can see here. So this is the meaning of AND operator with the mask. So the result like this, 1, 1, 0, 0, 0, 0, 0. But what's the issue here? This result of AND operator, it's actually not the correct result for this part. This part, if you put it here, side, how much? 0, 0, 0, 0. Okay, 0, 0, 1, 1. How much this number? This number, 192. How to know it? Okay, this 1, 2, 4, 8, 16, 32, 64, and 128. So 64 plus 100, 64 plus 128, it's 194. But look to the result. The result here is in hexadecimal, it's C000. In decimal, it's 3, 2, 2, 1, 2, 2. It's not 198 as we need. Why? Because this at the most left side. We need this number to come here at the most right side, not left side. So it's simple. After do this and what we will make here, shift. We will shift this number to come to its correct position so we can read it. So this operation have only one mistake, that the result needs shift. So how much the shift? How many digits we have here? Okay, it's 32 minus this digit, which 8 digits. So we have to shift 24 digits. Each one will be shifted 24 digits. So the correct operation is like this. After make the mask, and with the mask, the result will be shifted to the left 24. This is the operation, shift to the left 24. In this case, you will get the correct result. Okay. It seems complicated? No, let's see it in C language. It's not complicated. This in C language. How to write it? Okay, look here. First of all, we need unsigned. You have to focus. We speak about unsigned integer. If you make it integer, means it's signed, so the result will be different. Because when you make shift to the right, the sign will make different if you have signed. So we have unsigned integer. Here's the IP address in hexadecimal. The idea, this IP address in hexadecimal, we need to print it as 4 segments, like 1 to 9 point, for example, 15.10.2. So we have to print it as segments like this. Okay. So how to print it as segment? Each segment actually it's 8 bits. Yes. So we need this mask. The mask will be everything 0 except this one as FF. This first mask, because we speak about first 2 digits in the hexadecimal, it's equivalent to 8 digits in the byte. Okay, so first 2 digits will be masked with 111, 111, it's FF. Okay, other will be masked with 0. So this is the meaning of the mask. We speak here about everything in hexadecimal, yes? No, you can use decimal, you can use any type of number, but the compiler will do the operators or the operation in the bit wise, okay? So it doesn't matter this number, it's decimal, hexadecimal, or this number will be written in bit, even as binary, okay? At the end, it will be converted into binary, then the bitewise operator will be done on it, okay? And then the compiler will return it to the original value, okay? I think we don't need this one because we already print it. We will print it directly. So we don't need each segment as a variable. We will print the result. Okay. How many bits? We have 32 bits. Okay. And what's this temp? Temp is the segment value that we will print it on the screen. Okay. For loop from 1 to 4. What's this mean? Because we have 4 segments, we will take each segment, print it, then move to the next segment. Okay. How to calculate the segment? The segment value, it's the IP address and operator with the mask. So first time, it will convert everything into 0 and take this part. Okay, the result will be here as integer, okay, as decimal integer, except if you print it as hexadecimal. You can also print it as hexadecimal. It's depend on if you print using %d, it's decimal. %x, it's hexadecimal, okay? So it's depend. IP address, we know it, we read it usually as decimal. So I will print it as decimal. Okay, so what will happen here? So you have this one first time, first time you have this one, which is 201.0.8a.0c. This is the IP address, and the mask 0.0.0.0.0.0 Actually, after converted it, this one into bit and this one into bit, and you make AND operator, means you will delete all these digits and the result will be only these two digits, which is C0, and all remain will be as 0. Okay, but this number on the left, it's like when you write 9 and you have 0000. So this means it's 9 million, but I need this 9 as 9, so it must be here. Yes? To do this, you make shift. Same idea here. I need this number, but this number on the left, I have to shift it to be on the most right digit here, 0C, and other part will be filled by 0. So what I have to do, I have to shift here the result, which is temp. This one's the result. It's temp. I will shift it by how much? I will shift it. First time, I will shift it by 24. Second time, it will be here. So I will shift it by 24 minus 8. So it's 16 and so on. How to do it? The bit, which is 32, minus the I means which segment, first segment, second segment, third segment. Okay, multiply by 8. Like this, you will make the shift. Why multiply by 8? Because we speak about 8 digits for each one. So we have 32 position multiplied by 8. Okay. This is a shift to make this on the most right. What about the mask? First time the mask like this. Second time I need these digits. What's the mask to get these two digits? It's everything 0, 0, 0, 0, 0. Here F, F, and here 0, 0. Yes? So first time the mask like this. Second time I need this FF to come here. So the mask becomes 0, 0, F, F, 0, 0, 0, 0. How to do this? We will make shift. Shift by how much? Shift by 8, because each two digit here, in the hexadecimal, it's 8 in the bit. So we make shift 8 bits. If you make shift 8 bits for the mask, this FF will be moved here. So every time, you have to shift the mask also. Why? To take next two digits, then to take next two digits, then to take last two digits. Okay, we said if I not equal 4, we do this. Why? Because if I equal 4, this means we are in the last segment, then we don't need to shift the result and we don't need to shift the mask. We print it directly. If we are not in segment 4, then we have to shift the result, because I told you, if the result on the left means it's like 9 on the left, like this, it's 9 million, but we need it as 9, so we have to shift it. Okay, if the 9 here, we need to shift 4. If the 9 here, we need to shift 8. That's why we move the shift depending on the which segment. Okay, if last segment, we don't need all this shift. We print directly. Okay, so here, after we print each segment, we put dot to make it like this, 129.10, for example, dot 5 dot blah. Okay, we can run it here. This is the program. We have the IP address. We have the mask for the first time. Then this mask will be shifted every time by 8-digit, means 8-digit in the bits, or in the binary means 2 digits in the hexadecimal. So this means this FF will be shifted here, next time here, next time here as mask, because we know this mask tell us which 2 digits in the hexadecimal or 8-digit in the byte binary will be taken. So the result here, it's like this. Each segment, we take each segment, then dot here, then second segment, dot, third segment, dot, then last segment, we don't need dot. This one, print the last segment. Okay. So this is one of the use for the byte operator. Okay, let's check this one. Binary addition. Of course, we know in C language we can set Z equal X plus Y. If X 3 and Y 1, then Z equal 4 and finish. But let's see this operation, how it's work if we use binary addition. We will add the two numbers, but these two numbers as a binary system. When you speak about binary system, it's like this. 0, for example, this is 3, which is 1, 0, 1, 0. And this one, y, which is 1, so 1, 0, 1, 0, this is a 3. And y, it's 1, 0, 0, 0. How to add these numbers? Okay, the result will be 4, yes, which is 1, 0, 1, 0, like this, yes? When you make add 1 plus 1, it's 2, yes? 2, which is 0, and you have carry 1. So, if you said 1 here, 1 here, 0, it's not the result. So it's not working like this. It's working like this. It's not like the normal addition. You will see if you have carry or you don't have carry. If you take only 1 digit, okay, here, if you 1 plus 1, you have 1, and you have another digit, which is 0, so you have carry. This 1, 0 plus 0, it's 0, and 1 plus 0, it's 1. So, like this result. It's not like the normal or our decimal system. So we care about the carry actually in the binary addition. So as you can see here, we make the summation which using OR operation. So here X, which is 101, and we will have 4 digits, okay? And here Y, which is 1000. So I want to add them using the binary addition. First, I will make OR between them, or XOR, sorry, XOR. So if you make XOR between X and Y, make XOR. If they are similar, 0. If they are different, 1. Yes, like this, I take this digit because actually it do not have carry. This is the idea. The digits that do not have carry and have one side as 1, it's needed in the final result, actually. The problem when you have carry. So we have to know if we have carry. How to know if we have carry? By using AND operator. So same two numbers using AND. What's the result? If the result not 0, then we have carry. So we make AND between the numbers. If there is carry, then the result is not 0. So 1 and 1, the result 1. 0 and 0, 0, 0, 0. So we know that this digit have carry. So we need more calculation. So this is the idea here. So the result of the summation is 0, 0, 1, 0 here, not the final summation. We did not get yet the final summation. And we have carry, which is 1, 0, 0, 0. If we have carry, we have to continue the operation. If we don't have carry, then we stop and we get the summation. Okay. Okay, if we have carry, what we will do, we have to make summation again. So while carry not equal 0, then this means we have carry, then we have to continue the operation. What we will do, we will shift the carry to the left. So carry equal carry shifted to the left. So if we shift 1 bit to the left, this means it becomes 0, 1, 0, 0. Then x, the new value of x is the summation, which is 0, 1, 0, 0. This is the value of the summation from here. And y equals the carry. So we make x the summation from outside and y equal the carry after we make the shift. Yes? So it's 0, 1, 0, 0. Okay, now calculate summation another time, like here. So we have x, the new value of x, and the new value of y. Now make what? XOR if they are similar, 0 if they are different, 1. Okay, the carry equal x and y. There is something wrong here, I feel. Let me repeat the calculation again here. From here, I feel that something went wrong. Okay, let me see the carry again. So we have x, which is 3, 2 plus 1, it's a 3, and y is 1. So if we make XOR, it's become 0, 0, 1, 0, 0. If we make AND, so AND we have 1, other will have 0 because both sides must be 1. Okay, carry not equal 0, yes. Make shift 1 digit for the carry, so the carry become 0, 0, 1, 0. Okay, now x equals the summation, so x equals 0, 0, 1, 0. Y equals the carry, so y equal 0, 1, 0, 0, because carry equal carry shifted by 1. Now we make again another time for the summation. We make the XOR if they are same 0, if they are different 1, 1, 1, 0. So sum it's equal 0, 1, 1, 0. Okay, about the carry, it's AND. So it's 0, 0, 0, 0. So the carry equals 0. But this is not the correct summation. I don't know. There is something in the calculation. Let me run it and see. Okay, we have this binary addition. 3 plus 4. So it should be 3 plus 1. It should be 4. Yes, it's 4. So what happened in here? Let's run it step by step, debug. Here carry not equal 0, shift the carry, and x equals sum, y equal carry, and uh, there is something in the calculation that it's not correct because this one 1, 2, 4, so it's equal 6, but it must be equal 4. Anyway, later I can see the calculation and send the calculation for you, okay, as a picture, because we still have last example here. Okay, last example, it's to convert. Oh, well, what time our lecture should be finished? Our lecture should be finished 10:20, yes? Wow, I already take a lot of time from previous second lecture. I have to eat this very quickly and go for the second lecture. I have a lecture 10:30. I already missed around 25 minutes. So I will send you the example later, or I will tell the teacher, the lab teacher, to solve it with you. Okay, see you. Salam.